Today we'll be looking at how we can calculate or understand how a slope can be calculated from a graph that is plotted already. Remember, we have been plotting graph, learning how to choose scale, but what follow after the plotting the graph is some of the questions that comes with the plotting, like determine the slope of the graph, determine the intercepts, and so on. So for the purpose of this class, we'll look at how we can calculate the slope or gradient of a graph that is plotted already. Remember, we have what we call a linear graph. And normally a linear graph takes the form of y equal to mx. Y equal to mx, where x is an independent variable and y is a dependent variable. And m is what we call the slope. So if you vary x, there will be a corresponding effect on y. For example, if you take x to be 0, if you have x equal to 0, it means that y will be equal to 0. And if you have x equal to 1, then the value of y will correspond to the gradient. If x is equal to 1, then you have y equal to m1, which is the same thing as y equal to m. And if you have x equal to 2, then y will be equal to 2m, and so on. So from here, like I always said, you need to state the title of the graph, that is L in cm versus t square in second square as a title. Then looking at this graph, we can know the scale. So we are supposed to set it down. On this L axis, we have 2 cm to represent 20 cm. 2 cm represent 20 cm on the L axis. 2 cm represents 20 cm because L is in cm on the L axis. Then on this axis, we have 2 cm represent 1 second. 2 cm represent 1 second on the t square axis. 2 cm to represent 1 second because t square is in second square, and that is the scale. And look at the values that have been plotted here. 20 correspond with 0.9. 20 corresponds with 0.9. This is 1, so 0.9 is there. So these values are plotted like this. So we want to find out, and if you look at the best line of fit, we have 1, 2, 3, 4, 5, 6, 7. We have 7 points here. And if you look at these plots, we have 1, 2, 3, 4. This one is out, this one is out. So it is not possible, like I always say, for all the points to be on the best line of fit. So let's read out the points. This is the L axis, this is the t square axis. So like I said, you need to draw a right angle triangle. You need to draw a right angle triangle, and that right angle triangle will not be too small. So here we have drawn it. So you, at this point where the triangle meets with the baseline of it, you now extend it to the y-axis. At this point too, you extend it to the y-axis, which is l-axis in this case. So this point, you extend it to the t-square axis, and so on. So we have slope as change in L, because we plotted L against t square. Change in L against change in t square, which is the same thing as L2 minus L1. So in this case, all over t square 2 minus t square 1. That is the change in L all over change in t square. So in this case, if you look at this, this is our L2, and our L2 is 134. L1 is 30. Then T2 is 5.5, and T1, T square 1 is 1.2. And this is what what we have written here. And then using this formula, slope now be equal to 134 minus 30 divided by 5.5 minus 1.2. So if you evaluate this, you have 104 divided by 4.3, which is equal to 2.186 centimeter per second square. So this is how a slope can be determined. So the unit of the slope depends on the units of what you are plotting against the other. Thank you.